An auto policy will pay for damage to both policyholder's car and the other driver's car in the event of policyholder being responsible for accident. The size of payment for damage to the policyholder's car X has marginal density function of 1 for X between 0 and 1. Given X equals X, the size of the payment for damage to the other car Y has conditional density of 1 for Y between X and X plus 1. Given that the policyholder is responsible for an accident, calculate the probability that the payment for damage to the other car will be greater than 0.5. So it's time to get very comfortable with this notation. So the first thing we have is the marginal density function. X has marginal density function of 1 for X between 0 and 1. So the notation for that is F subscript big X of X, and we are told that it's equal to 1 for X between 0 and 1. And then we are told that the marginal given X equals X, Y has conditional density of 1 for Y between X and X plus 1. So given X equals X, Y has conditional density of 1. So that means F subscript big Y, Y given X, right? Because they said given X equals X. So that's the conditional density for Y, and that's equal to 1 as told when Y is between X and X plus 1. And we are to find probability Y bigger than 0.5. Calculate the probability that damage for the other car will be 0.5 and the damage for the other car is Y. So we need the joint PDF, and we know that the joint PDF can be written like this. F of xy is equal to F of x, the conditional density of x, the marginal density of x times the conditional density of y given x. So remember that when x and y are independent, then the conditional density of y given x is just fyy, and then we just have fxx times fyy. That's for independent variables. But if the variables are not known to be independent, then this is the most general formula. And you can also write this formula in terms of y. So you could also have f of big Y of y times f of big X, x given y. Okay. So, and both of these are 1, this marginal density and this conditional density. So the joint PDF would be the product of 1 and 1. And you combine these two conditions, that's x between 0 and 1 and y between x and x plus 1. So over here, it will be very helpful to just look at the figure and figure out the probabilities. So the total region is y between x and x plus 1. So this is the y equals x line, and this is the y equals x plus 1 line. And the total area is the area of the full parallelogram. And the yellow part is what we need, because we need the probability of y bigger than, not 5, but 0.5. Okay, so yeah, that's what we were asked. That is greater than 0.5. So y greater than 0.5 is the portion of this parallelogram which is above this line. This is the line y equals 0.5, and so this yellow portion is the one that is above this line. But you can see from the picture that it's much easier if we calculate the area of this white portion, which is just a triangle. And then the yellow area will be the total area minus the area of the triangle. And the total area, since this is the total area coming from a joint PDF, that's always 1. You can check it, but you don't have to, because this whole parallelogram, the total parallelogram is corresponding to this joint PDF, and therefore the area has to be 1 under of any joint PDF. So the area of the triangle, the white triangle, the base is 0.5 and the height is 0.5 because look, this is the y equals x line and this horizontal line is y equals 0.5. So when you substitute y equals 0.5 in the y equals x, both x and y are 0.5. So this length is 0.5 and this base is 0.5 because this base is the x coordinate and the height is the y coordinate of this point. So probability, so and this white triangle will be the probability that y is less than equal to 0.5. So that'd be half base height, that's this triangle. And so half times 0.5 times 0.5, so that's 1/8. And therefore the required probability, which is y bigger than 0.5, will be 1 minus y less than equal to 0.5. 1 minus 1/8 is 7/8, which is choice D.